right. Thank you, Leona. All right, so humor me for a minute, and let's take a trip back in time. Think back to the year 1942. There's a lot going on in the world back then. World War II was coming to an end. DDT was being spread across the landscape. And a fellow by the name of Robert Orr was taking a road trip across Idaho. I know this because according to Dr. Orr's collection records, he collected 2 of these guys, Magnum mantle slugs. And he probably wasn't too surprised to know that it was the first detection of the species in Idaho. But he probably would be surprised to know that it would be 68 years in 2010 before there was another detection of this species in Idaho, when field crews from the Multi-Species Baseline Initiative were trolling around the panhandle of Idaho and found this species to be fairly widely distributed around the panhandle. Now, the Multi-Species Baseline Initiative is a collaborative of several different organizations who are doing wildlife surveys and collecting microclimate data across the Idaho Panhandle and adjoining mountain ranges. Our study area is about 23,000 square kilometers, and what we did to make sense of this landscape is we gridded it out in 5 by 5 kilometer sampling grids. And our goal was to collect baseline information on 20 species of greatest conservation need listed in Idaho and Washington swaps, which are basically lacking basic information. We don't know if they're even on the landscape. We're just wrapping up phase 1, which is the field work of this study, and we're trying to jump into phase 2, which would be long-term species and microclimate monitoring. Now, our funded species for this project were amphibians, forest carnivores, and terrestrial gastropods. And what we did was in each of those 5 by 5K cells is we did a survey for each of those species. And not only did we look for those species within the cell, but there is some really cool microclimate monitoring techniques out there. Dan Isaac has a great stream temperature monitoring protocol, which we followed, except we plunked the monitors into ponds. And Zach Holden and crew has a very fantastic air temperature monitoring protocol. And we use these protocols to co-locate microclimate monitoring sites with amphibian and gastropod surveys. And to date, we've conducted standardized surveys at about 2,000 sites, and we've detected about 200 different species. And we've collected microclimate data at about 1,200 wildlife survey sites. Now, before we get into the climate side, we're going to talk about gastropods. Some of you may not know what a gastropod is, so this is your basic taxonomy lesson. A gastropod is a snail or a slug, and a slug is a snail without a shell. Now, I want to begin by showing you a picture of a dead gastropod, because this is a slug, by the way, because I want you to appreciate all the time and effort we put into getting beautiful pictures of live slugs. This is a smoky tail dropper. It's a Prophescion, and they're called such because they drop their tails when they're attacked by predators. And it's a very nice looking slug. If you'd like to just admire for a minute. Oh, this guy isn't quite as charismatic. This is Idaho sheath slug. And this very different looking slug is a pygmy slug, which I don't have a penny in there or anything, but it's small. This guy is I had to look this up. This is a humped coin. And it's actually a pretty snail. And this is a little guy too. Those are millimeters in the background. And the way we go about surveying for gastropods is basically we lay a transect out. We have our weather station up at the top. Then we do some slug traps, some pitfall traps. We do some time searches. We collect leaf litter. And this thing up in the right-hand side, it's a cardboard coverboard trap. And in Leonard's diagram, it looks super fancy. But really, it's just a piece of wet cardboard. And it's wet for a reason, because when you put them out dry, you catch nothing. And so we did a very important and highly effective scientific experiment, and we compared dry, water-baited, and beer-baited traps. And lo and behold, the beer works. And one of my proudest achievements in my professional career is chip in here, I got a letter from the state of Idaho stating that I was allowed to buy beer with my state of Idaho credit card for scientific research purposes. Yes. Yeah, we did our collections, and then we had 8,000 gastropods. I didn't know anything about gastropods at the time, so this left me in a bit of a stressful situation to finish my grant. So we threw ourselves a good old-fashioned gastropody. And fortunately, it wasn't just us yahoos. We were able to get Tom Burke, who wrote the book on Northwest gastropods, to come out and teach us a thing or two. And we were able to get through all our specimens in about 3 weeks. And that left us with our results, which were 58 gastropod species. 11 of those were new Idaho records, and 9 of them were new natives, and 2 of them were 2 non-native records for the state. And our results, remember, we were looking for rare species. We were looking for species that were listed as S2, S1, imperiled, critically imperiled species, many of which hadn't been found in decades and decades. And the results, when we compared them to all the other gastropods we found, were somewhat profound. So the red line there, these are just the percentage of cells that we surveyed that we found, all of the different native species. And if you look at the red line, those are our rare species. Those are the ones that we blew a couple $1 million in about 5 years of our lives on searching for. And it turned out that most of them really aren't that rare at all. And this points to a pretty interesting problem, is that we don't have the data that we need to be making these decisions on what's a rare species and which species needs conservation attention. And this is a problem. And what if we had that, though? What if we had that not only for species occurrence, well, not only for population changes, but what if we had abiotic factors as well? That's our fur pinwheel. We can skip that. It's super common, but it was imperiled. What if we had that? What if we had microclimate data to go along with that? So we took Zach's protocol and we put these microclimate data loggers out, air temperature loggers out at about 1,000 spots across our study area. Most people would stop at the city, but we just started knocking on doors and finding places where we could do slug surveys and hang up these things for a year. These data loggers, they collect air temperature every 90 minutes, and we had about 1,200 of them collecting data for 1 to 4 years. Now, this is what the data looks like. This looks like pretty good data. You can see on the left, it was in the truck, it was very hot, it goes out, and over the year it provides us very reasonable estimates of air temperature. Now, I was very excited to see this, but then you get ones that look like this. And you get, the first summer it goes out, it went out in June, everything's pretty reasonable, a high of 90. It goes out, and come late January, the thing levels out at 32, so it got covered by snow. And then the next summer is just a mess. It gets up to 114, which it doesn't get up to around here, at least not yet. Maybe next year. And so we're left with a little bit of a messy data. So to deal with that, we worked with Andrew Shirk at the University of Washington, and we put our heads together and we came up with a cleansing algorithm for the data. And we did a few different things, like we looked at the different, real climate stations, weather stations around the region, and came up with a maximum temperature, which we wouldn't allow the data. We came up with a minimum, and we looked at minimum, maximum ranges in temperature. And we came up with some rules that we would just eliminate data and say that is probably not real data. And kind of what that looked like, we're still working on this, but basically, for the purposes of this presentation, we just weeded out everything that we removed over 20% of the data, because we're going to talk about mean air temperature for the rest of the presentation. But it worked pretty good. I mean, the majority of them had pretty good data with less than 10% of the data removed. So we came up with a variety of metrics for our data, including mean annual temperature, number of frost-free days, spring, fall, mean annual temperatures, mins and max. And for this presentation, like I said, we're going to talk about mean annual temperature. And this data is from that kind of cleansed data set with at least 80% of the data across our study area. And basically what this is an air temperature map. Did I lose it? I turned it off. All right. This is kind of a rough draft. But basically, this is a surface air temperature map of our region, of our study area. And you can see the blue areas. I mean, we have these kind of cool microclimate areas where it's cooler. And we have some hotter areas. And our goal for this map is to kind of smooth this out and create a surface air temperature map that's basically a GIS layer that's available for use for people to use for climate modeling. And we're talking about using it for elk and forest carnivores and a bunch of different things. So bringing it into slugs. So just to get used to this map, ignore those little charts on the left for now. I'll show them to you in better detail in a sec. This is where we found native gastropods. We surveyed all of the cells that have hash marks or orange, and orange is where we found native gastropods, almost everywhere. Now that means I got 5 minutes left.
And you're talking in 5 minutes for questions.
Okay, I can do it. I thought I was going to be way behind. Okay, this is non-native gastropods. And so basically what we did is we found non-native gastropods basically in the valley bottoms. If we look at our native versus non-native in our little charts here, what we got on top, we've got elevation. The black line is where we conducted our surveys, and the orange line is where we found native gastropods on the top left. Basically, it just kind of shows that we found native gastropods pretty much everywhere we did surveys. If you go to the right, to the top right-hand corner, that's non-native gastropods, and you'll see that the majority of our non-native gastropods were at low elevations. And we see, not surprisingly, that's reflected in the temperature charts. On the lower left, native gastropods are about everywhere in the temperature scale, but then we see a bit more of a warm climate envelope for the non-native gastropods on the right lower hand side. Let's look at a non-native one just for fun. This is Limax maximus, it's the giant garden slug. So this one is a really cool one, and I wish I had a picture of what I'm about to tell you. But try to imagine, the way these slugs mate is they hang themselves from a piece of slime. They intertwine and they mate. And they do this like in people's yards, because these things are all over like Sandpoint and Coeur d'Alene. We get calls and I've never seen it. And this is like my dream wildlife sighting to see this happen. But it's super cool. They mate airborne. And they like it really warm. If we look at their charts, they're at low elevations, we find them in town, and we find them at very warm temperatures. Now let's look at one of our native species. This is the tail dropper, that really cool, pretty one. This one, actually, by the way, this was an S2 imperiled species. This is another one that was one of the most common ones in our survey. And it shows a slight preference for a little bit higher elevation, a little bit cooler temperature there on the bottom chart. Oh, and I want to show you a plant too. So I didn't have a way to like smoothly work this in, but this is Devil's Club. If you guys are from the Northwest, you should know it's the real spiny one that hurts. And so just at all of our sites, we looked for a bunch of different species. This was one. And I took some grief from some of our partners. Like, why do you want to look for Devil's Club? I was like, well, I got a hunch. And I was right. Because check this out. This is a species which occurs at kind of lower elevations, but it's also more associated with cool temperatures. So what's going to happen to species that actually occur at low elevations but are associated with cool temperatures as we approach a warming climate? If we look at all of our gastropods in a range, you'll see those last 5 bars on the left are 4 species in a genus, which I forgot to take out. But there's 4 species that kind of occur after that line drops off. And they occur 1 degree on average below the mean temperature of the study area, which is about 6 degrees centigrade. And this is the coldest one. This is the Magnum mantle slug. This is the one Dr. Orr found back in 1942. This species is our coldest associated species. It's found at higher elevations. And you can see it's got a very narrow climatic envelope of a couple degrees there. So the question is, what's going to happen to Magnum mantle slugs who have a temperature, appear to have a temperature tolerance range of only a couple degrees centigrade when global temperatures raise 2 to 4 degrees centigrade? And so obviously we have a long ways to go with our analysis here. And there's a lot of questions and a lot of uncertainty. But what is certain is that we can and we do need long-term monitoring programs for multiple taxa that address abiotic factors, especially climate factors. And it's also very clear that we can't wait another 62 years to look for Magnum mantle slugs. Thanks.
Stay here. We got lots of time for questions.
Oh man.
Anybody's got some burning gastropod questions?
Yes.
What happens to the project now? You finished it?
Well, we're out of money, but we're not out of spirit. So now we're actually having a meeting here in about a month with all the partners, and the idea of this thing is we could morph it into long-term monitoring, and so we're going to kind of butt our heads together and see if there's interest in going forward. And I think there is. And the really cool thing about it is we did have a big grant. We had a $950,000 grant from the Fish and Wildlife Service, but our budget was $2.2 million, and over half of it was partner contributions. And so our philosophy is kind of a stone soup philosophy. If we bring the stone, then there's just all these different agencies and groups that are doing wildlife work and wildlife surveys, and the idea is just getting everybody on the same page and using the same protocols, and we can create something that's really big and bigger than our agencies. Yes?
So this last slug, magnum mantle slug?
Yeah, you got it.
So it occurs at one of the highest elevations and lowest temperatures, and you were saying your last question is what happens when mean temperature rises. Is there any room for it to move up in elevation?
Well, that's a good question. In our study area, the elevations are actually pretty low here in the Panhandle. So in the Panhandle of Idaho, the highest elevation is just over 7,700 feet. It's 7,709. And they occur up to the higher elevations, but they also occur low. And there's some, you can see there's some outliers where they occur in warmer spots. So that's one thing we don't know is how flexible they actually are. And we don't know, is it really air temperature that's limiting them, or is it elevation, or is it some sort of habitat thing? And that's where we want to go with our analyses.
All right. Thank you.
Thanks.